Alright, today we're going to solve systems using elimination. Before this, we were able to solve systems by graphing. And then before, we were also able to solve by using substitution. So this is just another method for us to get to that same answer, to get to that solution to the system. So this is called the elimination method. We can add together equations to eliminate a variable. If at any time during this video you need it to pause so you can write things down, go ahead, pause, and then have the teacher play it again. In order to do this elimination method, you need the same coefficient and variable, but opposite signs. Same coefficient and variable, but opposite signs. So if I had a 3x, what would be the same coefficient and variable but opposite sign? Well, that means I would want a negative 3x. That is what we are looking for in order to do this in an elimination method. Alright, let's look at our first example. Alright, let's look at this problem. It says solve by elimination. Let's look. It says 5x minus 6y equals negative 32, and then 3x plus 6y equals 48. Look at the y term. Do you see how this says negative 6y and this says positive 6y? That means we're ready to eliminate the y variable. I can do this by adding my two equations together. 5x plus 3x would give me 8x. When I look at the y term, negative 6y plus 6y, that would just cancel out. So I'm left with equals negative 32 plus 48, 16. Well, I want to solve for x, so I'm going to divide by 8, so x equals 2. Is that my answer? Of course not. I need an x-y ordered pair. So remember, it's just like before. It does not matter which equation I plug it back into. I'm just going to pick the top one. 5, I'm going to replace that x with 2, minus 6y equals negative 32. Alright, well, we have to multiply first. So 5 times 2 would give me 10. Bring everything else down. Now I need to solve for y. So we need to move this positive 10 to the other side. So I'm going to do the opposite. I'm going to subtract 10 from both sides. So I get negative 6y equals negative 42. Divide by negative 6. So y equals 7. So my final answer, of course, needs to be written in my xy form. So final answer, 2, 7. Alright, let's look at this next problem to solve by elimination. So I have my system of equations. 2x plus 3y equals 11. Negative 2x plus 9y equals 1. Well, look, what variable are we going to eliminate here? It looks like the x's, because I have the same coefficient, but opposite signs. So we are going to add these equations together. We're always going to add. So what will happen to my x term? They'll cancel out. I will no longer have any x's. So 3y plus 9y would give me 12y. 11 plus 1 is 12. We got to solve for y. So I get y equals 1. Of course, not my final answer. I can pick either equation to plug it back into. Let's pick this one, the top one. So I'm going to say 2x plus 3. Instead of y, we're going to plug in what we just got. 1 equals 11. Well, 3 times 1 is 3. Subtract 3 from both sides. So I get 2x equals 8. Divide by 2, so x equals 4. So the final answer would be 4, 1. Alright, let's take a look at this problem. Solve by elimination. So it says 2a minus 3b equals 61. And then 2a plus b equals negative 7. Well, there's two things that are different here. We have, instead of x and y, we have a and b. But looking beyond the variables, if you look at my a's, here I have 2a, here I have 2a. I have the same coefficient, but I do not have opposite signs. And in order to solve by elimination, I need opposite signs in front. So how are we going to make them have opposite signs? Well, we could pick one equation. It doesn't matter which one. I'm going to go with the bottom one. And how will I make them have opposite signs? We're going to multiply everything by negative 1. So now this equation will say, okay, negative 1 times 2a is negative 2a. Negative 1 times b, well, a negative times a positive would be a negative b, or negative 1b. And then negative 1 times negative 7 would be a negative times a negative, a positive. So now, by multiplying all three parts, and yes, it always has to be all three parts, by negative 1, I have flipped the signs. So if you look at that bottom equation now, and go ahead and rewrite the original top equation, stacked on top of it. Now we could do elimination. Now we have the same number in front, but opposite signs. So I'm ready to add these two together. My a terms will now cancel. Negative 3b minus b would give me negative 4b. 61 plus 7 would give me 68. Divide both sides by negative 4. So now I get b equals negative 17. Alright. It does not matter which equation I plug this back into. I can pick this top one, I can pick the bottom one, or I could even pick the one we multiplied through by negative 1. I'm going to go with this bottom one. 2a plus b equals negative 7. So we're going to plug in b equals negative 17 right here. So I get 2a minus 17 equals negative 7. Add 17 to both sides. So I get 2a equals 10. Divide by 2, so a equals 5. Well, how am I going to write this as an ordered pair? We're just going to go alphabetically. So a comes first in the alphabet, so it will be a, comma, b. So 5, comma, negative 17. And we're done. Alright, look at this elimination problem. Go ahead, write it down. Negative 2x plus 3y equals 25. And then negative 2x plus 6y equals 58. Well, looking at my equations here, it looks like the x term has the same coefficient, the same number in front, but unfortunately it does not have opposite signs. That's okay, we can make it have opposite signs. We can pick one equation. Last time I picked the bottom equation to multiply by negative 1. This time I'll just pick the top. You only have to pick one. We need to make them have opposite signs, so we're going to multiply everything by negative 1. So a negative times a negative, now this will be positive, 2x. A negative times a positive, that would be minus 3y. And negative 1 times 25 equals negative 25. You need to make sure you multiplied all three parts. Alright, now just rewrite that original bottom equation. So now, it seems like we have same number in front, opposite signs. We add them together. X terms cancel. Negative 3y plus 6y would give me positive 3y. Negative 25 plus 58 would be a positive 33. Now I would just divide by 3 to solve for y, so y equals 11. Alright, does not matter which one we plug it back into. So I can just even pick the bottom equation. Negative 2x plus 6 times no longer y, we're going to plug in that 11, equals 58. Well, 6 times 11 will give me 66. So in order to solve for x, next step, we're going to have to subtract 66 from both sides. So now I get negative 2x equals 58 minus 66 will give me a negative 8. Divide by negative 2. Oop. So x equals a positive 4. So final answer would be 4, 11. You are going to try these two problems on your own. Pause the video and then play it when you're ready to check your answers. Alright, hopefully you got those answers. Go ahead, copy down this word problem. So we're looking for finding two numbers. The sum of the two numbers is 32, and the difference is 4. Well, I don't know what these two numbers are, so I can just let x represent the first number. And since it's another unknown number, I can use y to represent the second number. There are a bunch of key words in that first sentence. The sum. What does that word sum mean? Addition. Of two numbers is, remember is equals 32. So when I add these two numbers, these two unknowns, I get a result of 32. The second equation says the difference, which is subtraction, is 4. So when I subtract the two, I get 4. Do you see how this is set up for elimination? Look at my y's. I have the same number in front, that invisible 1, but opposite signs. So when I add these two together, and be very careful, X plus X would give me 2X. My Y's cancel out. 32 plus 4 is 36. So I can divide 2 by both sides. So my first number is 18. My second number, I need to pick either one to plug it back into. We could just pick the top one. So plug in 18 for X. So now this will say 18 plus Y equals 32. And what am I going to do to both sides? I'm going to subtract 18. So I get Y equals 14. So I would say, okay, we can put it as an ordered pair. We can put it as an XY since it's a word problem. Let's double check. When I add 18 plus 14, what do I get? 32. When I subtract 18 minus 14, what do I get? 4. So I know I have the correct answer. All right, next. All right, go ahead, write down this word problem. Okay, it says tickets for a baseball game cost $5 for adults and $1 for students. The attendance that day was 1,139, and they collected $3,067. Find the number of adults and students that attended. Well, that last sentence tells me what I'm looking for, my two unknowns, right? The number of adults and the number of students. So let's say what our variables are. We can use A for adults, for the number of adults. And S is fine for number of students. Be careful about how you write your S's so they do not look like 5s. There's lots of information in this word problem. It talks about the cost and then it talks about the number of people. Let's talk about just about the money. Look at everything that has a dollar sign. $5 for adults, $1 for students, 3,600 or 3,067. So what would $5 for adults look like? Well, 5A. If each ticket costs $5, we can represent that as 5A. $1 for a student, so I could say plus 1S, which equals that total, 3,067. Not only did they talk about the money, they talked about how many people attended that day. So the second equation is going to be the number of people. So together, the adults and the students, they equaled 1,139 people. Alright, this is almost set up for elimination. We can draw in our invisible ones if that helps us. If you look here, I'm almost ready to eliminate the S because I have the same coefficient, but I don't have opposite signs. So let's multiply this bottom equation through by a negative 1. So now that's going to switch my sign. This is going to become negative 1A minus 1S equals negative 1,139. Go ahead, rewrite that original equation on top. Alright, now we're ready to eliminate. We can add the equations together. 5a plus a negative 1a would give me 4a. My s's are gone. 3,067 plus a negative 1,139 would give me 1,928. Now we just have to divide by 4. So how many adults were at this game? 482. Now let's figure out how many students. I'm going to go back to this bottom original equation. I'm going to say, okay, A, 482. So I'm going to plug that in for A. 482 plus S equals, just subtract 482. So how many students attended the game? 657. So there was 482 adults at the baseball game and 657 students. Okay, get ready to practice.